Hey guys, welcome to Deep Dive Coding. Today we solve LeetCode weekly contest. That is question number 3, and question name is split and merge array transformation. So question is basically says that we are given two integers array, that is nums1 and nums2, and that have the same length and also permutations of each other. Nums1 is permutations of nums2, and we have to do a following operation, that is split merge operation, and using these operations we have to equate nums1 to nums2. So we have to return the minimum number of operations required to transform the nums1 into the nums2. So if you check that, we are given that nums1 and nums2 array, and let's say nums1 array is a1 a2 a3 a4 a5 a6 and a7. So we take any subarray from this array. So let's say we are taking subarray of A3, A4, and A5. So if we take this A3, A4, and A5, then remaining array would be the A1, A2, A6, and A7. So what are the, now we take that subarray, and now we have to again place this subarray into the remaining array, and how many possible positions is already there. Like there is a possible of the remaining dot size plus 1. Over here we can place before 0 and 0 to 1, 1 to 2, 2 to 3, and after the 3. So there is always remaining dot size plus 1 possible insertions. So we insert all these positions and check whether it is possible to whether it is equal to nums2. If it is possible to equate the nums2, then we simply return the how many operations already done previously. Okay, so let's say you insert the positions at the 2 to 3 index and add the remaining array. That means over here, that is a6, in between a6 and a7. So one permutations of the nums1 can be a1 a2, because of this one, like a1 a2 a6, and then we place that a3 a4 a5 and finally a7. This is the operations we have to do each time, and this is the single operations. Now we have to return the count how many minimum number of operations is required to convert nums1 to nums2. So if you guys see this constraint over here, so over here it's important information is given, that is 2 less than equal to n, and nums1 and nums2 length is same, and that goes up to maximum 6. And another important thing is nums2 is the permutations of nums1. So if you, here is the one important note is this one, like nums2 is a permutations of nums1. That means we always find a finite answer, because we can each time each time we do the operations, and it will generate a new permutations of the nums1, and that permutations are eventually after some operations are equal to the nums2. So we always find a finite number of operations. So we can write some observations over here. So what we are saying over here is that nums1 and nums2 length is same. So we write that thing, nums1 and nums2 length is same. Okay, and uh, let's say their length is denoted as n. So n max value is over here given, that is 6, and actually the range is 2 less than equal to n and less than equal to 6. This is given in the range. And second observation is, can we generate all possible combination, all possible permutation. That means we are first we are trying to see that whether we can apply the brute force or not. So if you think carefully, that number of possible, how many number of possible permutations is n factorial according to formula, and that is, so n max factorial would be n max factorial equal to 6 factorial, and that will 720. And after that, let's try for the brute force to generate all possible all possible of subarray, brute force operation. So that will be like generate all possible subarray, and that will take the n square complexity, that will like big O of n square complexity, n square, that means n square operation. And the second thing is each for each subarray we insert the remaining array in the, that will be done in the big O of n. And for each insertion we generate the new subarray, generate not new subarray, that generate new array, that is the permutation of nums1, and that will be done in also big O of n time. So it's total it takes big O of n to the power 4. This is the time complexity to get to each brute force solution. So if you think that n max, so if you calculate it, n max to the power 4, that would be the 6 to the power 4, and 6 to the power 4 equal to, if you, okay, so it will be the 1296, and so combine can be time takes combine operation would be big of n factorial into n to the power 4. This will be the total time complexity. So if you check that this thing, that n max factorial into n max to the power 4, that will eventually 720 into 1296, and that will give you 9, this one, 933120. This will, so you can say that it will be 1e6 at max. This is only the max, because you can say that at max. So these many operations is always acceptable under the time constraint. So we can apply the brute force solution. So answer is, so we generate all possible subarray, all possible combination, all possible permutations, and that is always acceptable. So we try to do the brute force solution. Now let's try to analyze the approach. Now we start from nums1, that will be the our first permutation state, and next is generate all such permutation according to given operation. Okay, and third thing is so yeah, and we check if it is equal to nums2. If it is equal to nums2, then simply return the how many steps required to reach there. How many steps required to reach current state from nums1. And third thing, if it is not the same, then we further explore all state from the current state using operation. So to do these things, like to count how many steps we already required, so we have to track the distance array. Let's say dist array. That will means that this simply means the distance between current state from nums1. And second thing is we have to store each of the current state to explore the next states using the operation. So we have to do this way, that permutation state, each element will looks like this way, that permutation state comma distance, and this we are using queue to do the operations efficiently. For each elements in the queue will be look like this way, that permutation states, first element is the permutation states and second element is the how much distance it takes from the nums one. Okay. Now also we take a visited set so that we should not explore the state again. Okay. Now I directly jump into the code. And also if you think about the space, I will discuss the later. I will discuss later. Now let's jump into the code directly. Okay. First of all, we take the size of the n, that is n equal to nums1 dot size. And as question is given, nums1 dot size and nums2 dot size is equal. That will I will take that is only n. So first of all, we check that whether already nums1 equal to nums2 or not. If it is equal, then we do not need any operation, so we return the 0. And after that, we take a q as discussed below. That will take a pair, and this will be the vector int comma int, and this is q. So it will take the that it will take the element as permutation state comma distant. Now we push that q first element, that will be nums1 is the first state and distance is 0 because that is calculating distance from nums1 only. And after that we take the set that will be visited, that will inside that state, inside that set element is be vector int, and this is the visited. That means vector int will not grow much because already over here it's given that its maximum size is 6. So inside that vector always the size will be the 6. Also this operations is not takes much time, that is nums1 equal to nums2, because that will also take the big of 6, that you can say that considered as big of one time complexity. And now we take that visited, and also we visited to, we are inside that thing like visited dot insert nums1, because uh, we already in the current state of the nums1. Now we go into the queue. Each let's take all elements in the queue one by one, and let's try to calculate next permutation state. So we take as auto current permutation comma dist equal to q dot front, and we remove from that queue because we already explored, we are currently exploring this thing right now. So as discussed, we brute force all permutation. So that will be done in, I let's L equal to 0, L less than n, and L plus plus. Now for int r equal to L, r less than n, and r plus plus. Okay. So we are taking the L to R as a subarray. Now we separate that thing like subarray. Let's take a temporary of that subarray. And also another thing is the remaining array. Taking a vector of remaining array. Uh, yeah, remaining. Yes. Okay. So yeah, we take these two things, and after that we iterate. We are feel that sub array and remaining array. That means we separate from that array. So equal to I less than n and I plus plus. Okay. And if it is I greater than equal to L and I less than equal to R, that means if it is in L and R, that means it is the part of subarray. So we simply take that consider in the subarray current permutation of I. And if it is not the part of the subarray, then it will be in the remaining array. So we simply push back there current permutation of I. Yeah, it will separate subarray and remaining array. After that, we just insert the each positions. So we iterate over. So what we are next try to do this, the insert the extracted subarray to every possible position of remaining array. Now we go I equal to 0, I less than equal to remaining dot size and I plus plus. Over here we are taking that equal because it will take remaining dot size plus one possibility. So it starts from 0 till it go for remaining dot size. So it will take the remaining dot size plus one possibility to insert that thing. So we take that new vector, that will be the new permutation, and simply copy that thing. Like uh, first of all, if it is anything remaining for remaining dot begin, remaining dot begin plus I, and back inserter of new permutation. I will explain what over here happening. And after that, first of all, I have to write. And after that, we copy from the subarray. That will be the subarray dot begin, subarray dot end, and again back inserter of new permutation. And at last we copy from the remaining dot begin plus I, remaining dot end, and back inserter of new permutation. Okay, over here it will copy in the new permutations array from remaining dot begin till remaining dot begin plus I. But this last, that is remaining dot begin plus I, that ith index of the remaining, it will not included in the first go, and it will include it because that will define in the STL. And after that, over here also, that subarray dot begin it till subarray dot end, but last one is excluded from that new permutation. And after that, we are again starting from ith element of the remaining, because that is not inserted previously. So that start from the I, and that will appending till the end. So you already copy the new subarray, we build the new subarray. Now we have to check whether it is possible equal to the, that is nums.2. If it is equal, then this will be the minimum distance. Why? Because this will be the first state we reach over here using the distance. So this will be the minimum distance. Like we are exploring the state in iterative way. So if when we explore the state, we reach the state in the nums2, then that will be the how much distance it travel. That will be the minimum distance. And so at last we like at last we have to find that whether it is already visited or not. If it is equal to visited dot end, that means it is not present in the visited array. So we simply insert that thing in the visited array, visited set, that is new permutation, and we have to again push that state in the queue so that we further iterative way to next go to the next state. And that will insert in the distance plus one, because it will take distance plus one steps to reach current state from the nums one. And at last we are going to minus one return minus one, because it is the invalid state. This state, this portion of code will not execute. That means it is not according to given constant over here. That is, it's always possible to get some distance. We always get some distance. It is not possible that we are not able to find the distance, because nums2 is the permutations of nums1. And now let's try to run the code. Yeah, it's run for the sample test case. Now, as we already discussed the time complexity of it, now discuss the space complexity of it. So we are taking the space of the queue, that will be take the all the permutation state, and apart from queue, we are taking the set that will take the vector as an element. So at the OR scenario, all the states of the permutations that under in the queue. So that will take, as in the time complexity, that will n factorial into n to the power 4 states is always possible. So and even in the visited this one, that is visited. Over here also the number of states, that will be the n to the power, sorry, that will be the n factorial. So you can say that over here we finally write the time complexity. Time complexity will be n factorial into n to the power 4, as well as space complexity would be the same, like n factorial into n to the power 4. Now this is the time and space complexity, and let's try to submit this code. And if you guys found anything helpful, please write in the comment box. Thanks for watching. Stay tuned for the more videos.